The mass extinction event that wiped out the dinosaurs is arguably the most popular and devastating extinction in Earth's history. But while a lot can be said about the moment the asteroid hit the Earth, the most devastating blow to our planet were the moments that followed. Join us in today's video where we take a look at what the Earth was like after the dinosaurs. The day the asteroid that wiped out the dinosaurs hit was just like any other day on the planet some 65 million years ago. The asteroid is believed to have been up to 15 kilometers in diameter, but it hit the Earth at such high velocities that the impact crater it created was over 150 kilometers in diameter, the second largest on the planet. The impact site, now known as the Chicxulub crater, was the epicenter of what would become a devastating chain of events that was felt in every corner of the planet. The impact explosion is estimated to have been more powerful than 100 billion tons of TNT, which is over 6 million times more powerful than the Hiroshima explosion. The blast from the impact sent a heat wave traveling at nearly the speed of sound and instantly vaporizing any living thing within a 300-mile radius. If the same asteroid were to hit Earth at the same spot today, the blast wave would vaporize you in Texas, leave third-degree burns in Panama, deafen you in New York, and shatter glass windows all the way up in Iceland. But the moment of impact was just the beginning. The hours that followed were a lot worse. The impact sent subterranean shockwaves through the Earth's crust, such that earthquakes could be felt on the other side of the planet in less than an hour. The earthquakes that followed would have been unlike anything in recorded human history, and would be the equivalent of all the earthquakes in the last 200 years, going off all at once. The tsunamis that followed were unlike anything we've ever seen, reaching heights of over 1,000 feet with waves that reached every major shoreline on every continent on the planet in under 10 hours. The next 24 hours after the impact would have been a scene from an apocalyptic movie for the dinosaurs. The blast wind would have traveled halfway across the planet, moving at speeds of up to 600 miles per hour, leveling anything that might be standing. The blast from the impact sent millions of tons of debris into the atmosphere, some of which moved at such speeds that they broke from the Earth's gravity and went flying into space. A vast majority of this debris came flying back into Earth like burning bullets, but at much higher speeds and bigger sizes. This burning debris wiped out a vast majority of the dinosaurs across the Americas and Africa, as the continents were still much closer than they are today. The cascade of burning debris started wildfires across the planet, effectively killing off much of the vegetation at that time. The days following the impact would have been marred in near total darkness across the planet, as soot and erupting volcanoes released a thick haze of smoke and ash that filled the atmosphere, blocking out the sun. And although the impact of the asteroid itself devastated much of the dinosaur population on the first day, it was the string of environmental effects to come that truly wiped out the dinosaurs. The nuclear winter. While earthquakes ceased and tsunamis receded, the atmosphere had only just begun its own devastation on the planet. The atmosphere was nearly pitch black in the months following the impact, resulting in less than 10% of total sunlight reaching the entire planet. Without heat from the sun, much of the planet plummeted into a cold, icy winter, with entire oceans freezing over and freshwater sources becoming inaccessible to animals. There were little to no sun rays for photosynthesis, and as such, plants that didn't burn up from the wildfires simply withered and died out. With very few plants to produce oxygen, CO2 levels rose, making the air practically unbreathable to most animal life. The asteroid impacts had also ejected massive amounts of sulfur-rich crude oil into the atmosphere. This, in addition to the vast amounts of ash in the air, returned to the ground as acid rain and mud. The amount of toxins produced by all these would have temporarily destroyed the planet's protective ozone layer, leaving the planet susceptible to harmful solar radiation when the clouds finally cleared up. Experts estimate that the global carbon footprint at the time was about 100 billion tons of carbon dioxide, 10 billion tons of carbon monoxide, and another 100 billion tons of methane present in the atmosphere. This period of nuclear winter is estimated to have only lasted a few years, but that was more than enough to deal the final blow to the dinosaur population. Most non-avian dinosaurs were wiped out in the first 24 hours of the impact, but whatever was left was subjected to unusually long winters with no fresh water, reduced food sources, and a poisoned atmosphere. The asteroid had successfully wiped out over 75% of all plant and animal life on the planet, with almost all land animals, including dinosaurs over 25 kilograms, completely wiped out. The extinction of the dinosaurs marked the end of the Cretaceous period, which lasted between 145 to 65 million years ago. The gradual transformation. Following the extinction of the dinosaurs and much of the vegetation that filled the Cretaceous period, which were mostly ferns, another set of plants and animals rose to fill the evolutionary gap. With all land animals over 25 kilograms completely wiped out, smaller mammals became the most widely populated land animals on the planet, marking the beginning of the Paleocene period. You might be wondering how these mammals, which were no larger than mice, were able to survive a string of devastating events that killed the big and powerful dinosaurs. Well, the answer is in their sheer size. These small mammals were able to survive as they could easily burrow underground and hide from the burning and later freezing temperatures on the surface after the collision. While larger dinosaurs perished from freezing temperatures and lack of water and food, these small mammals survived on underground water and fed on smaller insects and microorganisms. These mammals had more diverse diets and were simply more adaptable to changing conditions than the dinosaurs. A few decades after the collision, the atmosphere had all but cleared up, and finally sunlight shone on a devastated world, almost devoid of life. Temperatures rose, and with increased greenhouse gas emissions, the planet warmed considerably, melting frozen oceans and rivers, making way for life to begin again. A few thousand years after the collision, flowering plants that had also existed at the time of the dinosaurs were becoming more widespread than the ferns that dominated that era. By 100,000 years later, mammals had doubled their population and were widespread on every corner of the planet. They had increased in size, with the biggest land mammals now reaching 20 kilograms, and over the next 200,000 years, finally reaching the 25 kilogram mark. These new mammals were mainly herbivores that took advantage of the highly nutritious seeds of flowering plants. In return, mammals played a crucial role in dispersing the seeds of these plants to new regions that were devoid of plant life. Although mammals also existed during the time of the dinosaurs, they were on the low end of the food chain, but less than 1 million years after the extinction of the dinosaurs, they were at the top of the food chain. The continental drift. Biodiversity wasn't the only thing to experience a complete change following the asteroid collision. The continents also continued to drift further apart, a process that had started some 200 million years ago when the supercontinent, Pangaea, began breaking up. Although the continents had already split at the time of the asteroid collision, Australia, India, and Antarctica were in different positions relative to their current locations. While Australia and Antarctica were still in the southern hemisphere, much like they are today, but so was India, which was a massive island, or continent, at the time. Some experts believe that the sheer force of the asteroid impact might have sped up the separation of the continents. While Australia and Antarctica moved further away from the other continents, India was headed on a collision course with the supercontinent Eurasia. At around 15 to 25 million years after the dinosaurs, India collided with Eurasia, with the sheer force of the collision pushing the edge of both landmasses upwards, giving rise to the Himalayas we see today. Human evolution. Humans might be the apex species on the planet today, but our species only diverged from our mammalian ancestors, the primates, some 300,000 years ago. Homo sapiens were some of the most rapidly developed species, considering all we've accomplished in the last 10,000 years alone. But one question comes to mind. If the asteroid that wiped out the dinosaurs hit today, are we equipped enough to survive? Or would we be wiped out like the dinosaurs were?